So in part 2, we're going to talk about what is a mixed radical and what is an entire radical. But what I want to talk to you first of all is to recall what we've been doing in this last class. So if we have something like the square root of 8, and we're asked to simplify this, okay? Simplify the square root of 8. All right, how many of you remember what to do here? There's a few different options that we had, right? I showed you a couple different methods. I like this one where you split the 8 into factors of, 2 or more factors, but if one of them is a perfect square, then you can simplify this. So 4 times 2, 8 is 4 times 2. If you keep that all under the radical sign, then it's no problem, right? You've got 8, and that's the same as 4 times 2. One of the properties that we talked about of radicals is that you could split each factor into its own radical and multiply the square roots of each factor, like this. And for me, this is the way I would opt to do it, because I notice here now that the square root of 4 is what? Is plain old 2. And so your final answer here, simplified, is 2 root 2. Now you know to stop, because underneath the radical sign, there's no more perfect squares. So 2 is prime, so it's 2 and 1, and neither 2 nor 1 is a perfect square that can be simplified. Yes, 1, you could be taking the square root of 1 out all day, though, and never stop. So we don't consider 1 as a perfect square, right? All right, so here's the thing. This right here is an entire radical. That's what this is called. Entire. E-N-T-I-R-E. And if you've ever, you know the word, right? Entirely. That means all of it. And so if you think about all of the numbers or all of the terms, everything is underneath the radical sign. So that's an entire radical. And this one here is a mixed radical. It's a mixed radical because we have regular numbers or coefficients, okay, regular old numbers, and we have radicals, or the square roots or cube roots or fourth roots. So this has got two distinct parts, and that's called a mixed radical. Okay. Now in this section, the big thing we want to do is we want to be able to rewrite each radical in both forms. Now, not every radical can be simplified to mixed. Like let's say we have the square root of 7. There are no perfect square factors of 7, so this is simplified. All right. You can't really write this as a mixed radical. But let's say we took this right here, this answer, 2 root 2, and let's say we wanted to write it again as square root of 8. Okay? Well, if you just look at the reverse process, okay, if you take the number out front and you square it and put a root sign over top of it, that's where we came from, right? We simplified here, so guess what? Let's go the other way and square it and put a root sign. If you take the square root of something and you square it, they cancel each other out. Those processes just cancel each other out. So really, you are not changing anything. So if I actually square 2 and put a square root underneath it, I've got the exact same value. Does that make sense? And if you rewrite whatever's left there, and you do this process in reverse, then you have this, right? So there is a way, and it's a pretty quick way actually. I'll show you that in a second. It's a pretty quick way to get from a mixed to an entire radical. So let's do some more examples with square roots only. So let's say we've got, well, going from entire to a mixed is just simplifying, right? So we've done that already. Let's go from a mixed to an entire radical. So what about 3 root 5? Okay, how do I write that as an entire radical? Well, the method that I just showed you, you could do this. The square root, 3 is actually the square root of what? 9 times what's already there. See, because this is 3 times root 5. So 3 can be written as root 9 times root 5, which is root 9 times 5, or root 45. Okay? So 3 root 5 is the same as the square root of 45. And just to double check on our calculator, 3 times the square root of 5 is that, 6.7, and the square root of 45 is the exact same number. All right? So you can always check to see if your conversion is right. All right, let's speed it up here now. 2 root 2. Whoops, I just did that one, sorry. Let's not do 2 root 2. Let's do 2 root 10. 2 root 10. You may be seeing this already, and here's a step that you can do. You can just skip to this step if you want. You say, all right, this is a square root, and this number I need to get inside there as a factor. So if a number wants to go into a square root sign, what do you have to do to that number? You have to square it. So you can say, hey, this is actually 4 times 10, or root 40. So the square root sign, and I've kind of taught it this way before. If you think about this square root as kind of like it's kind of like a door to a club, okay? And everybody in here is in the square root club. But everybody out here wants to get into the square root club. So they're lined up at the door here. And in order for them to jump into the square root club, they have to get squared. Okay? So basically, this number 10 here is saying, hey, 2, if you want in here, you got to get squared, man, to come into the square root club. So 2 says, fine, I'm willing to do that, to be in the square root club. So it comes in there as a factor, and it says, okay, now I'm a 4. Fine. Get that? Square root club. Now, what about if it's a cubed root club? A cubed root club. So let's say we have an example. Yeah, if you think about it as the cubed root club. Oops, what's that? All right. Then let's say we have 2 cubed root 5. Now the 5 is already in here, right? And if I wanted to take 5 out, it would have to get cube rooted. But it can't get cube rooted. There's no factor of 5, and it's not itself a perfect cube, so it's in there. But the 2 wants to get in. How do we get the 2 in? To the cube root club, it's got to get cubed. So 2 gets cubed to come in. You see? So it's 8. 2 becomes 8 when it comes inside the cube root club. So here it's outside as a 2. Now it's inside as an 8. And so we have the cube root of 40. And of course we can double check that, can't we? So, calculator again. Where do we start there? 2 times the this calculator. 3. Where is it? Oh, I do have a cube root there. Okay. 2 times the cube root of 5. Okay, that's how you put that in the calculator. And then the cube root of 40, and I did see a cube root function there. Good. Cube root of 40. Nope, that's not right. Oh, I put the wrong number in here. Sorry. This should be 2. Thank you. So let's do entry. Thank you. I put the 3 in front. Okay. So there we go. See, cube root of 40 and 2 times the cube root of 5. There we go. Same number. Okay? All right. Let's do another example. What if you have 5 times the 4th root of 3? Okay, this is a mixed radical form. Let's put it in entire radical form. Okay, why don't you take a half a minute and see if you can do that based on what we've been doing. All right, so you can check up the board there when you're done, just to see if that matches up with what you did. This 5 really wants to get into the 4th root club, so it's got to get 4th. So 5 to the power of 4 inside. Right? It's just a 5 outside, but it's a 5 to the power of 4 once it comes inside. Because the 4th root of 5 to the 4 is actually 5, so it doesn't change itself. So that's 625 times 3, 1875. So please don't forget to write the 4 there, right? And please do show your work. I don't want to see this and then all of a sudden just that. You need to show your communication so I know what you're doing. Okay? Any questions so far? Any questions? All right. Let's work through a couple things here. I don't know. Did you guys get? I assigned you 11 from last day. Did you get number 11? Because we can go over a couple questions from number 11, perhaps, like 11 what? H. Want to do 11H? Oh, I only assigned ACE. Okay. Let's do E then, and C. Well, again, so I'll do 11E because that's when I started. So cube root of 60. Now, if we wanted to simplify this, again, what you want to do is you can do a number of things. You can prime factorize, right? 60. I would suggest trying to find a factor of 60 that's a perfect cube, if you can. And if you can't, then it can't be simplified. So what are the factors of 60? Well, 1 and 60, but we can't use 1 anyways. So 2 and 30, 3 and 20. What else? 4 and 15. 6 and 10. Okay. So is that everything? 5 and 12. Okay, is that everything? Now you look at this list. If this is all the factors, if you look at this list and you try and find a perfect cube, can you find a perfect cube here? If any one of these are a perfect cube, then you can use that. But if you don't see a perfect cube, so what are the perfect cubes? 2 cubed is 8. 3 cubed is 27. 4 cubed, 64. So already we're past, right? So that cannot be simplified. It says write each radical in simplest form if possible because there are no factors of 60. Okay? Make sense? Let's do I. I know I didn't assign you I, but we're just practice here, right? So cube root of 500. So same thing. I would suggest that you run through the list of factors, of factors, but of perfect cubes because this is a cube root. So are any of these a factor of 500? What about 5 cubed? What's that? 125. So does that help, I wonder? Is 125 a factor of 500? Yeah, it's 125 times what? Well, so here you go. This is what you do, guys. All right. So you go 500 divided by 8. Let's see. Nope, not a whole number. That's not a factor. 500 divided by 27. Nope, definitely not a factor. 500 divided by 64. If you don't know the answer to this, then there you go. Just keep going. 500 divided by 125. Whoops. 125 is 4. All right, there. Now we're cooking. So the cube root of 125 times 4. You see, 125 can get out of the cube root club. It can actually escape because it's a perfect cube. And it comes out of the club as 5. Capiche?